I know, and also this is going to be probably
I don't remember.
if you yeah, like if you say print, we're going to change it to red. It's so easy to red color. I don't have to do that like exactly.
Oh. All right, everybody. Let's go ahead and start. It's 3:30 now. All right, so let's start by, I think we'll do this for one more lecture, like today's lecture, and then there's other games that we can move on to. Okay, so as y'all know, it shows the country outline. We have to guess the country, and we'll try to get closer and closer. Does anybody have an initial starting guess what they think this is? Anyone just want to say a country? It's okay if it's far from
Ukraine.
Ukraine. Whoa, 95% though. So I think that means we're really close. We're a little bit to the west. Yeah.
Czechia or Slovakia?
Yeah, it's one of the others.
Maybe
It is one or the other? Okay, let's do Czechia. And then Slovakia. Wow, okay, we got it. That was pretty easy. That was a good first guess. I think the first guess got us there.
I know the silhouette. It's just that.
Oh, you didn't want to say it in the right. Oh, nice. Well done. All right, everyone. Let's get to some announcements. All right. Actually, there's a decent number of announcements today, so try to pay attention during this part. So one, I just want to reiterate our policy on like academic integrity and using like outside resources. You are like heavily encouraged to use online resources, okay, including ChatGPT. Obviously, GitHub Copilot. We're going to cover that this lecture and next. So it's also not something you have to like hide from. You should tell us how you're using GitHub, ChatGPT and GitHub Copilot in your process journals. Okay, feel free to Google stuff. You can just Google like I have to add this new feature in idle. How can I go ahead and do it? Like whatever you think is going to help. The way that you would get in trouble is if you and your like partner, like a friend in this class, have like just told the other person what the answer is, and you sort of like copy that, okay? There should be a process where you struggle to figure some stuff out, understand part of the code base, and then make the change, okay? So I know it's, obviously a little bit hard for us to detect if that happened. One is, this is like an upper division class. It's mostly for, y'all's benefit. As you know, I think I'm a bit more lenient with the grades. If you need an extra couple of days, you can take it, so try not to, please don't do the approach where you just get an answer from a friend. The goal here is to struggle through a project for a little bit and then come to office hours. I promise we have like, hints set up for each of these projects. Like after 1 week, I'm gonna give you a hint for project 3 if you're still stuck. Maybe you saw that we did the same thing for project 2 for like the checkpoint, okay? So yeah, long story short though, feel free to use online resources. Next is project 2. Actually, sorry, project 2 is due today. But, with the 24-hour grace, I guess technically that means it's due tomorrow. What we're requesting, though, is we want to get these grades back to you by, like, Thursday night, basically. So if you have finished it right now and the pull request is final, can you just go to that pull request and comment, like, I'm finished or I'm done, this is, like, the final one, if it's not already specified somewhere in your pull request. We're going to start doing the grading, like, this evening. We really want to, like, have this sort of like classroom culture of immediate and often feedback. That's also something that is like an agile like software development process of getting quick iterative feedback, improving on it, and then making the changes based on that review. So if you could even just like right now comment on the pull request if you have finished. We'll start doing the grading tonight and hopefully have it by Thursday. Again, the grading is going to be very similar to last time, but for this project too, you can expect to have to implement some changes, okay? We sort of have like a template of all the things that we're looking for, everything from the high level implementation, like what approach did you actually use to, like what code changes did you make, to like the code style, how much like white space do you have, are you using like camel case or snake case, okay? These are the things that maybe you don't think about so much, especially before this class, because you just have to maybe pass some test cases. Maybe there's a little bit of grading on like code organization, or did you use a for loop correctly? But we're gonna try to make this as realistic for like code reviews in industry as possible, where we'll give even more like minute feedback that you're just gonna have to make some small changes to fix, okay? Are there any questions on project 2, deadline, or grading? Okay, awesome. Then the next one is project 3 is released. This is due next Wednesday. Remember, this is the project where you have to add a code outline feature. We're going to talk about that a little bit during today's lecture as well. But I just want to point this out. We're going to have project 3 released. You also have, like, for the 4th announcement, you have the group project proposals due this Friday. I think just getting a little bit of progress every day, every couple of days is really helpful here. And then come to office hours or post on EdStem if you are struggling with a certain part. We'll do our best to sort of give you the hints, okay? Don't feel like you shouldn't ask a question because you have to like struggle through for hours and hours before coming to office hours. I don't want that to be sort of like the question asking culture here. Please come to office hours, and we're gonna do our best to give you a little bit of hint, a little bit of guidance, but not revealing what direction you take, right? So get started early and then come ask us for help. The next one, okay, this is the big one, all right? The group project proposals are due this Friday, May 3rd. We're gonna request that you don't use the 1-day extension here if possible, because our goal here is that on Friday night you'll all submit it. Over the weekend, maybe like Monday morning, we'll review the proposals and let you know which project proposal to go with. If you really do need the extra day, you can let us know for this one, because we definitely want to let y'all get started as early as possible and sort of just give y'all as much time to work on it, okay? So a couple things about this, make sure you have a team by now. I think some people have been posting on EdStem, which is great. So if you're still looking for a team, just check a couple posts on EdStem. Hopefully we don't run into this issue, but it could be possible where like, instead of having 12 groups of 4, because I think we have 48 people enrolled in this class, there might be some groups of 2s and 3s that would potentially have to like break up to make the 12 groups of 4. If we're stuck in that state, you can just let me know that you're not able to find additional people. Maybe we can work something out for having less than 4 people. Yeah, question?
For accept the group assignment, so there's a button that we should create a team. For the team name, what should we put?
So for the team name?
Yeah.
Oh, you can come up with any cool team name that you want. It could be something funny or creative. Like you can do anything you want there. It doesn't have to have your team members' names or anything. Eventually, y'all will we'll have your GitHub account associated with each team, so you can call it anything that you want. But it should be like not bad or inappropriate, basically. Okay, and also I haven't had any of these discussions yet, but hopefully over the next 2 days at office hours, like feel free to come discuss project ideas with us, okay? We can give you some guidance on like whether something is like too difficult to propose, and maybe you can tone down, the requirements that you're proposing, or we can maybe like help you figure out what would be a good sort of idea for a project, okay? The project proposals are a kind of significant part of this project because it's going to sort of determine how the next 4 weeks goes. So investing a little bit more time here planning out, I think will really help y'all down the road. Okay, the next one is that we have a new reflection survey. So as project 2 wraps up, we're going to do our best to basically every 2 weeks have a new reflection survey and feedback form. We are curious again how the class is going. So please let us know if the class is still going well or not, or any things that might have changed. Phone. I don't think so. Would it have been up here or somewhere else?
Well, it's been over here, but
Anybody find the phone? Okay.
I think.
Oh, nice. Okay, awesome. So, like I said, the reflection survey, again, please be brutally honest here. This one, again, actually, you know what? I'm going to accept the emails for this because I'm curious the actual response. Okay, verified, right? Let's just do Okay, so this one is not going to be anonymous like last time. So the reason is because there's some questions on here about like how y'all are feeling in terms of like confidence for the different program comprehensions that need to be covered. So that's the only reason. We just want to be able to know like how people did on the project and correlate that with how confident they are on these different program comprehension techniques. I still urge everyone to be honest here. I'm not going to hold it against you if you have some negative piece of like feedback or any constructive criticism. I think that's sort of like what I'm looking for here. Okay, so yeah, answer these questions. We also have some specific questions about how project 2 went, about the difficulty of it. Please let us know how your experience with that was. And lastly, for exploration activity 2, okay, I covered this at the end of last lecture, and we didn't have time to do it as an in-class activity, so I sort of assigned it as this. I think I apologize for not being so clear with like exploration activity 2 was assigned on Thursday and then due before class today. I think I just mentioned that verbally. So it's okay if you haven't actually finished it yet. Try to do it by the end of the day today if possible. The goal here is just for you to be able to do the activity using sandboxing or just making these smaller workspaces to test out some different library or framework. Please try to work on that today. I promise it's going to help a lot with project 2. I'm actually going to start today's lecture showing my responses to a couple of them. So if you haven't finished it yet, maybe you just follow along, replicate something similar after class, and then submit your responses. Yeah, question.
Is it possible to make the surveys send you a confirmation after?
Oh yeah, that's a good suggestion. Thanks for that. Maybe we can try to make that the default. You mean for like the reflection surveys, for example, or all of the even like the exploration activities and like everything in the class? Okay, let's try to do that. I guess Cushy or Charles, can one of y'all maybe for the participation forms today, and then the reflection survey and any other currently active forms that we have, can you just do the send respondents a copy of their responses? Okay, that's a good suggestion. We'll try to do that from now on. Okay, any questions on these announcements? Any questions? Okay. The next one is code walkthrough presentations. Okay, this is like the next assignment that I'm sort of introducing for the course. This, I think we still have a lot of time. You have about 4 or 5 weeks, and eventually what you're going to be doing is just creating like a 12-minute presentation with your team project about a part of the idle code base, okay? So you'll be using like the debugger, doing a demo in front of the class. You'll be making some slides, making some diagrams. Maybe you'll make some experimental code changes or like demo a feature in action. The goal here is for y'all with your project group of 4 people to sort of do a deep dive on the code structure, code organization, how a feature works, and then do a technical presentation to the class, okay? These technical presentations are a very common part of industry, and I think, from like my friends being in industry and so much research that I've read, one of the biggest sort of like obstacles that students encounter once they get into industry is the technical communication aspect. So that includes stuff like communication with managers, but also there is an actual process of giving technical presentations with slide decks, good visualizations, and then the slideshow itself becomes a part of the documentation, okay? So that's kind of what the goal of this project is, or this assignment is going to be, for as a team to make a 12-minute technical presentation about a specific feature, okay? You can think of it as giving a presentation to your coworkers that are on the same team, but that haven't worked on that part of the code base, okay? So we're gonna have signups for these where as a team, you will just write out like the feature or the file name or the module, like the class, tailor it to a very specific part of the code base, a narrow feature, Similar to how in class, like we'll just show like the update sidebar text. I think you can do a whole 12-minute presentation just on how update sidebar text works. So think in that level of granularity, or just maybe like the line numbers feature. And what you'll do is you'll write out the team members, okay, like the 4 members that you have, and then write out the specific topic, okay? And maybe say the feature name, the file name, method name, anything to make it sort of clear what your topic is, because it's going to be like a first come, first serve basis for the topics, okay? There's more than enough, there's 12 teams, so there'll be lots of potential topics to cover, but we can't have people sort of repeating the same topic. Yeah, question.
Are we going to be
presenting, is this presenting our feature or is it just something already existing?
Something that already exists in the code base, but it can be something that's related to your group project. So for example, say your group project is related to, I don't know, making a lot of changes to the format region class. Okay, the format region is what does like the comment region event, comment out region, like indents and stuff. Maybe you end up learning a lot about that class through your project that is adding a new feature related to that. But you have some overlap from what you worked on in the group project, and then you can be like, okay, let's just present what we've sort of learned from the group project. Okay, but this is not going to be your group project presentation. That is what's going to happen during the final exam. Okay, you're going to just present your new sort of like feature to us, similar to the code walkthrough presentation, but with not as much emphasis on like the code comprehension of it, mostly just like the design of the feature and what the feature does, maybe like showing us the feature in action. Okay, yeah, question?
Will that final group presentation be in person?
Yeah, that'll be during the final exam slot on like June 10th. I think June 10th, 2 to 5 p.m. is the final exam slot, and that's just going to be presentations. Okay, there's not going to be a final exam or an assessment in this class. If you're definitely not able to make that final exam slot, let me know now, and let me know, if you're willing to share, able to share like the reason you're not able to. We can try to work something out. It might involve just making a short video ahead of time for your part of the group project presentation. But those will be in person, not recorded. Yeah.
How is this walkthrough be graded?
Yeah, I'm gonna release a write-up for it, hopefully like Thursday or Friday. I just want to let y'all start thinking about it now. It'll be graded on probably just the quality of the demo and the like explanation. So it's definitely gonna be a bit, I think, hard to grade because there's some subjectivity in assessing like how good was the communication. I'd say don't worry too much about the grade, because I think as long as you do a code walkthrough presentation with doing like, so the write-up will have like, you have to show like 2 of the code navigation code comprehension techniques that we covered in class. So like a diagram, the debugger, code navigation. As long as you do that and maybe like have a decently well put together slide deck, then I think y'all will get a pretty good grade. Okay. Any other questions about this? So, like I said, sign up earlier if possible. If you're going to be doing a topic that maybe other people would want, you can sign up for this later as well. I just want to give y'all plenty of time to think about the topic here and start coming up with your presentation. Okay, I will give out like a write-up of this, like a more formal write-up definitely this week. But start thinking about the project right now. And as you can see on the schedule, this is going to be happening in week 9. Okay. And if the presentations go over, I think we do have some time next week, like on week 10. But I think the goal will be to fit the 12 presentations in the 2 lectures. Okay? Awesome. Any questions on code walkthrough presentations? Okay, great. So I want to wrap up talking about the sandboxing from before. So just as a reminder, when I say sandboxing, what I sort of mean here is having like a development workspace or environment outside of the big code base that we're working in, right? It would be like a little bit excessive to be making a bunch of experimental code changes in the idle-lib code base just to understand tkinter a little bit better, okay? So I just want to go over a couple of these. Maybe I'll just do the first and the first and the last questions, and then leave maybe sort of the other questions up to y'all to do as part of the exploration activity if you haven't already. But also, like, this first one is very relevant to project 2, okay? So, does anybody know, actually, just the answer, why do we have, like, the end minus 1c in, I think, let's do end minus 1c like this. So, what was the feature? Was it here? Forget what, do y'all remember what, in the exploration activity, which part of the code base did y'all have to find out? Oh, update side text, yeah, thanks. Let's do update. Okay, so, yeah, can anybody tell me what is the end minus 1c? And like, specifically, why do we have the minus 1c part? Yeah.
So minus 1c expands to like minus 1 character.
Yeah, and do you know why? Like, why can't we just do n? I don't know. Anybody have an answer to that? Yeah, let's go there. Ricky.
Okay, so if we do just end, we'll go past the actual end of the file, of the line. So like, for example, if we have 13 lines, if we do just end, it'll return 14 lines, which is like one off from what we actually want.
Okay, yeah. So the answer was like end would basically be giving us one extra line than we want. So like really I'm more interested in like how we go about finding the answer to this than what the actual answer is. So I'll just show sort of like what I have done for this. Here's like maybe a good way that I would sort of approach trying to figure out what the like -1c part does specifically. So this is the code from last time. I think, you know, if you did something similar where you went on ChatGPT and requested some starter code for tkinter, it might have given you something different. We're going to cover like why these large language models give slightly different answers every time. But it's okay if you have like a different setup from this, right? The main point here is that we just want some code to give us an environment that creates like a tkinter text widget, and then we can sort of like do the rest from there, right? And that might involve some Googling or maybe another couple of ChatGPT commands, like how do I just like access all of the, you know, lines in a text widget or something, right? Luckily, the prompt that I had given gave us this, like text widget.get 1.0 to n -1c. So what I did for this is like, let's just keep it as n for now, and then let's print out len lines, okay? And it's helpful here that we already have the starter code that just like splits all of the content by a new line, and then we can, you know, we're printing out the lines in the text widget, right? So what, you know, you could sort of do for this, let me make sure this. So when we run this, and then I do read lines, it shows that there's actually 5 lines, okay? And you can sort of see that I'm actually not able to click below line 4. Gosh, I wish I could make this bigger. But if you're not able to tell, like I'm on the very end of the last line, and I like actually can't go down to the 5th line, okay? Like I'm not able to put my cursor there or start editing from it. I'd have to like press enter, okay? And then when I press enter and then do read lines, now it's 6, okay? Even though, you know, we can sort of clearly tell that there are only 5 lines active in the editor. But then maybe what you can do in this sort of like line of experimenting, you could do like -1c to actually see what's going on here. And we'll have the same unaltered code to print out the length of the lines. And then let's run this after saving it. And now when I do read lines, we can see that it's only 4, right? And again, the same sort of like concept is there, where at the end of the 4th line, I'm not able to go to the 5th line, okay? So what's actually happening is, I think we had even covered this in one of the like test sidebar classes, or one of the tests for sidebar. It was like -1c, oh yeah, I think right before. So this is just sort of like a quirk, or I guess maybe a design decision for how the tkinter text widgets work, is that there's always, you can look at the comment here actually on line 248, that the text widgets always keep a new line character at the end of the text widget, okay? But that's not something that we actually, as the user, are able to like go to and start modifying, okay? So, hopefully for project 2, you have, I think some of y'all have done, there's maybe like 2 different ways to approach project 2. I think one of them has a better code quality approach, and one of them is maybe not as good of like a change to the code base. We'll give this feedback all in the project 2 code review, but hopefully you can use this like information about n-1c and figure out how to get like the maximum number of lines using using like the text variable, okay, in the go to line event. I'll just leave that as, if you haven't figured it out yet, basically the sort of like last minute hint I'll give you here is that you can do something very similar to what we just did in the sandboxing to figure out how to get like the total number of lines in self.text, okay? And the reason we sort of know this is because self.text is like the tkinter text widget that we are sort of like creating in this like smaller environment here, okay? So if you want to like figure out how to get the maximum number of lines, I think a better approach to just making like a bunch of changes in this code to like try all these different techniques for getting the maximum number of lines, I think it's a lot easier to actually just make that change in a smaller environment like this where you don't have to run idle lib, access the feature, see what is printed out. You know, you can do it in a much more simple manner here. And then one other thing I wanted to cover was this text widget state, okay? I'll just show a demo rather than sort of like asking how people approach this so we can get on with the rest of the lecture. But basically the takeaway here is that you should be able to sort of Google some of the documentation related to tkinter, and I'm actually just going to show you a couple of the good resources for y'all to use for Project 3 and Project 4. Honestly, it's just a simple like Google search of tkinter documentation, but this tk docs is sort of the specific documentation for tkinter, and there's a lot of like helpful sort of like an organization for what exactly you need, okay? And so I think here they have the text widgets. Oh yeah, for more widgets, you can go to the text widget, okay? And you can see a lot of like example code on like, you know, setting the states to be disabled, or how to deal with like the font sizes and like the width of the different windows, okay? So definitely recommend using like the official documentation for these things, and also you will get to see, you know, examples of code. Okay, I'll just quickly show this right now, what happens when we make the state disabled, okay? So let's just look at what is going on here. First, we create the text widget, and then before we even have the insert command, I'm gonna just set the text widget to have a disabled state, okay? And then when I run this, there's no like lines that are actually shown in this text widget, in this like text widget demo, okay? And you know the sort of reason that we can figure this out by just changing the location of where this text widget state is. If we now move it to after insert, okay, and I'll save it and run this again. Now the lines did pop up. I have lines 1 through 4, but you know, you might not be able to. I'm trying to like click here to get to the cursor and like, you know, make some changes, but I'm not able to do that, okay? And you can read about it in the documentation. What this state disabled does is that it prevents any sort of like changes from happening to the text widget, whether that's from the user or any future commands that might be like an insert command to like add some text to the tkinter widget, etc. Okay, so that's just maybe a couple examples. I won't go over the next two. I think we had 2 other questions in the exploration activity. I think you can sort of figure that out through googling the tkinter documentation, reading about the insert method. But yeah, I think I'll leave it at that, and hopefully this can give you some more insight on how some of these different operations work in the idle code base, because we were just able to do some small scale experimenting. Are there any questions on this sandboxing or tkinter? Okay, just a quick review of the techniques we've learned so far. I think this was something in the feedback. I just want to make sure we're all sort of caught up here with what we've learned. And the expectation here is that y'all should start using this in like a structured manner as you go about understanding the code for Project 3 and Project 4, okay? So remember, we have the code navigation features. This is for understanding more like the text structure, maybe the code organization and relationships between it. The debugger was more for like stepping through line by line, seeing like the different values of variables. We have experimental code changes. This is more for like understanding the purpose of the code. You can sort of find out where the Python prompt is implemented by making like a small change and then like running it. Reading test cases, very helpful for understanding the expected like input and output of different functions. Diagramming, maybe more for like an abstract, high-level understanding of relationships. And then finally, we have just-in-time learning. This can sort of be ad hoc and like as needed. You'll sort of use this to maybe understand some like external dependency, like tkinter. You might just have some questions about advanced Python syntax, like we talked about last week. So I want to cover this, keep this in mind. Hopefully, y'all can sort of start using these for whatever problem comes up, right? Like maybe in project 3, you just need to figure out like where should I even begin editing code to like add some menu option. Maybe you want to, I don't know, make some experimental code changes or look at some diagrams of some key classes to understand, you know, how things are sort of like implemented and where the code that you want to add should belong. Okay. All right. I'll leave it at that. Now we'll spend about 5 minutes hearing from Charles. He has a couple of helpful VS Code extensions, rather than features. These are extensions. And yeah, Charles will just take it from here. Do you need the adapter or?
So, I'm honored to present here. And glorious day today. And I had 3 hours of exquisite sleep yesterday. So, yeah, really. And so I'm introducing you to 2 VS Code extensions that are extremely helpful in my daily life, at least that's in my opinion. One of them is called tab out. So look at this piece of code, and it's for demo purposes. So when you have like layers upon layers of function calls, especially in functional programming, you have layers upon layers. You want to navigate through those parentheses, but it's like really frustrating if you move your mouse around. So if you want to improve your efficiency, you want to be more efficient navigating through the lines, you enable this extension. It's called tab out. And there we go. Tab out. And so you have your cursor here, and you want to go into the next layer of this layers of parentheses. You just press tab. Oh.
I think, wait, do you disable it right now, Charles? Yeah.
Now it's enabled. And you can just tab, and it will move your cursor to the next layer, which is nice gadget to have. And the next one is called LLMs. And this one is particularly helpful if you are programming in languages like Rust, where the compiler is like a god that you have to obey. You have to follow the supreme commander. So, especially for compiled languages where you don't want to have frustrating compilation errors, you can enable this LLMs, and you will have those errors displayed, highlighted in this orange font. Font 1 is not defined. This is eventually it's just revealing what's going to be hovered, like what's going to be revealed. You hover your mouse cursor over font 1. Essentially, we'll set it here. We'll display it in line, so you won't have to move your mouse that much. It's also a nice gadget to have, And one more thing, there's one trick I learned recently where you can edit multiple lines simultaneously, multi-threaded approach. So you just press Control-Shift-Alt, and then you press arrow keys, like up and down. And now you have editing access to all 6 lines in the meantime, all 7 lines. And you can, if you're programming in HTML, you can do A tag.
Wait, sorry, Charles, can you say the shortcut again? What was
It's Control, Shift, Alt, and arrow keys, up and down. Up and down your cursor. And I don't know if the same shortcut I don't know if the shortcut is the same for Macro. Is it?
I'm not sure.
It's a Command Shift Option.
Command Shift Option, there we go. We have Angela helping me out. And when you are programming in HTML or sometimes System Verilog, you have this feature is going to be really helpful. multiple lines to edit, www.google.com, and then you created 7 links, one edit, which is just saves you some time. It makes your keyboard navigation in code base to be way more efficient than if you move your mouse around. Other things. Also, you see that my VS Code ID looks a lot better than yours. It's pleasing, isn't it? Right? So there are a lot of extensions on this. I think theme. If you search for theme, this one I really like. Pale9 theme. You can install that one, and your IDE looks aesthetically pleasing, isn't it? And it's probably good. Oh, by the way, this material icon themes, it's the best. Let's just say that. It shows your files as with icons, which is brilliant because when you are navigating within a large code base and you have an icon as an indicator of what type of file that is, it saves you a few microseconds comprehending the code base, I guess. Oh, that's about it. And thanks for the time.
Okay. Sweet. So let's go ahead and get started with LLMs and programming. We'll spend a couple of days on this, so I know we did, spend a lot of time at the start, but I think we have plenty of time to cover all the features here. Also, I do want to point out to Charles that even without the theme, you can still see the icon of the thing, so it's not all bad with the regular
The
version.
material icon theme looks better.
Yeah, it actually has the color of the Python, and yeah, I bet there's definitely cooler parts of it, but yeah, I'll probably install a theme. Okay, so let's cover LLMs in programming, okay? So this is a very new topic, all right? Even in the computing education research community, we're not really sure how to handle the advent of GitHub Copilot and what sort of skills we need to teach to future software engineers now, okay? I do wanted to say though, it is getting very popular, and there's already quite a few research studies on the impact of it. There's lots of companies that are signing up for GitHub Copilot Business, some very big companies as well. I've also heard more anecdotally from people in the industry that these different companies are making their own sort of proprietary LLMs that are trained on their code base, their documentation, so it won't have to rely on sort of an open source LLM like GPT or something, okay? So this, I think, is going to be something very common that you'll start working with in industry. But with that said, though, different companies do have different policies. I know some companies are strong, no, you can't use ChatGPT or input any code on ChatGPT because then that's sort of data that is sent to Microsoft or whatever company sort of runs the large language model that you're working on. So I'm not saying that whatever you got in industry you should download Copilot and use it on your proprietary code base, or same with ChatGPT. There's some very real proprietary concerns here, so make sure you sort of abide by whatever company you're working at with this. But with that said though, a lot of developers use it, whether it's allowed or not in work. I think a lot of people are started using at least outside of work, personal projects and stuff. And then yeah, there's some really cool studies about the productivity impacts of it, speed up in terms of the amount of time, or speed up in terms of completing smaller code writing tasks, okay? So just a bit of an overview. I just wanted to show this figure here if people are interested. This is a wide scale sort of survey of developers and talking about the impacts of ChatGPT on their productivity and well-being. A lot of developers feel that they're a lot more productive, also less frustrated, more fulfilled, more time doing satisfying work. So these are, I think, some of the big benefits of using these things. I think something like developer productivity and well-being is a really important part for like the company's whatever bottom line, but also just, software engineering can be a very taxing job. So I think using these tools effectively can really help y'all out with well-being and stuff inside and outside of work. As maybe wild that sounds, I really do think that this can make life a lot easier. Okay, so I do want to just spend a couple minutes talking about what GitHub Copilot is, or what a large language model is. I'm sure some of you already kind of know what a large language model is, but I think understanding what it is going to help a lot before we dive into how it's actually used in our code base. Okay, so at its very core, you can think of like large language model as autocomplete. And admittedly, this is not like my research area. I've just taken a few classes related to NLP, so I'm not an expert in this by any stretch. But this is definitely a high-level understanding of how these sort of technologies work, okay? This figure here kind of shows a very, very simple version of how a large language model works, where there's some like input tokens, is what they're called. Tokens would just be like words, or maybe in programming specific like syntax features like a semicolon, the for keyword, a parentheses, stuff like that. And fundamentally what these models are doing is looking at previous patterns and predicting what should come next, okay? So when we have the prompt that is the cat likes to sleep in the blank, there's a whole sort of process of figuring out the probability of the next words, okay? So there's, every single word that has actually ever been inputted into the large language model is going to be assigned a probability. A lot of them will probably be 0. But you'll see that it'll be sort of lower probabilities like this. But then what happens is, in a semi-random process, one of these more common words is going to be inputted into the blank, okay? So I had mentioned something before that you might have had the exact same prompt for ChatGPT that I did, but got a different output for the tkinter text, okay, or the starter code. That's a word, a concept known as non-determinism, okay? So I'm actually just gonna make a new non-determinism, okay? This is maybe a word that you'll hear quite frequently associated with these large language models. What this means is that so if a function is deterministic, or if something is deterministic, it means that when you have an input x, then you can always tie it to some output y, okay? So if you have a function that just, adds 3 to any inputted number, okay? If you input the number 4, it outputs 7, that's a deterministic function. You can easily tie the input to an expected output. If something is non-deterministic, then we lose that sense of guarantee that a required input or an input will have an output, a consistent output, okay? So what this means is that these large language models are going to have a decent amount of variability when you all use it, okay? When you give specific prompts, even in the context of the idle-lib code base, you're gonna get different code suggestions, and you're gonna get different levels of correctness, basically. So I'm hoping that this sort of figure can just help y'all have a little bit of suspicion whenever you interact with these large language models, because at the end of the day, it doesn't actually the large language model doesn't know what the sentence "the cat likes to sleep in the box" means, and it's this is getting a bit philosophical about whether these things can actually think or understand human intentionality. But for the moment, it seems like these things don't. And so have that level of suspicion, I guess, that it's really just pattern matching and showing what is typically the word that follows whatever you've inputted, okay? And I'm going to show some funny examples, or some common examples of how in the idle-lib codebase, GitHub Copilot produces maybe even something that's completely inaccurate or a bit nonsensical, and that's just going to be part of the experience of working with these LLMs, okay? So just takeaway here, have some suspicion when working with these things. Okay, so I'm going to cover this later, actually. I think I sort of already covered the high-level abstract version of this, but this is basically just showing all the data that GitHub Copilot uses when making a code suggestion for what to autocomplete your code with, okay? Long story short, it uses the tabs that are open in your workspace. It'll use the currently open file, and there'll also be some other data that is sort of the base data, or the training data for the large language model, which will already be a lot of Python code, a lot of Java code, etc. but then it'll be sort of like fine-tuned is what it's called. It'll be more specific to your workspace because it'll also use the data that's in whatever VS Code files you have open. Okay. So, how is Copilot used for large code bases? For these next 2 lectures, we're going to focus specifically on GitHub Copilot, okay? Hopefully you have it installed. If you don't have it installed yet, only one of the 2 activities today will actually require us using it, but Thursday we're definitely going to be using it heavily, and then there's going to be a whole project about it. Let me know or post on EdStem if you're still unable to get it downloaded and enabled, okay? So, I mentioned that like understanding how GitHub Copilot is used in a large code base is somewhat understudied. This was like, it was one of the best papers at one of these big conferences in programming languages and software education, and software engineering. It's actually, UCSD actually is like a really big research institution. We have so many amazing researchers in so many different fields. This is done by Nadia Polikaporova. I'm not exactly sure how to pronounce her last name, but she teaches programming languages. And this paper looked at how software professionals use Copilot and what are some things that are effective strategies and what are some things that are ineffective strategies, okay? So I want to start with just this sort of like high-level understanding of what it can do, and then I promise we'll get into starting to use it for the code base, okay? But this, I think, really helps understand, like, when should I be using it and how should I be using it, okay? So what they did for this study, long story short, they took like 17 programming professionals and actually watched them as they programmed and asked questions as they programmed, and they sort of come up with a theory of like, how do people use Copilot for large code bases, okay? Sorry, this is not for large code bases, this is just for a program writing task. So I think they had to write, a few functions of code, but it was people who are very familiar with programming already, okay? So there's sort of like 2 different phases of using GitHub Copilot. One is the acceleration phase and one is the exploration phase, okay? The acceleration phase is when we sort of like already know exactly what we need to do. Maybe we already know like, okay, I'm gonna have 3 functions. The first function is going to find the number of items in a list. The second one is gonna find the length of all the items in the list. And the third one is going to take the average of the first 2 functions or something like that, okay? That is when the developer knows what to do, and then the Copilot basically just speeds up the actual writing or the implementation of what the developer knows to do, okay? The next is exploration. This is like when you're starting a programming project or starting to work on a large code base and you don't even know like where the starting point is, and you need this like understanding of where in the code base you need to be working with, and maybe like what specific objects or classes are going to be very relevant, okay? I'm going to start with this acceleration part, okay? And then we're going to do an activity related to this. So from this study, these are a couple quotes from it. This quote I thought was really interesting. It said, "We observed that language expertise or familiarity with Copilot seems to play less of a role in determining whether a participant would engage in acceleration compared to their understanding of the algorithm for solving that task," okay? What this means is that what is more important than like knowing Python or Java or C or knowing what GitHub Copilot can do is having an understanding of what like steps need to be accomplished to do that task in the first place, okay? And then the sort of like a couple other suggestions here are when you just have like very big sort of like steps like I don't know, add a feature and then test the feature, those are 2 not very helpful steps because if we task Copilot with a very big ask, a very big prompt or a step that is like, like adding a whole feature or like writing a whole, couple functions, think of it as like we're giving a request for one task that might be correct with like 30% probability, okay? There's maybe only like 20 to 30% chance that we get the solution we're looking for. Versus, 6 or 7 smaller logical units, 6 or 7 smaller steps that are like maybe 80% more, like 80% likely to be accepted or like correct by Copilot, okay? So hopefully that's a little bit of intuition on why this process of decomposing your task is really important for Copilot to help with acceleration, okay? So actually, like one of the takeaways from this study is planning is very important for a developer to be able to like break down a task into these smaller sort of steps, okay? And so I want to actually start with the first activity. This is gonna double as some maybe like hints for project 3. Okay. I think project 3 is gonna get a little bit complicated, so you can consider this maybe like a hint for doing project 3. We're gonna do this first task where you, like, I think a lot of y'all haven't started project 3, and so that's sort of what my expectation is here. Even though you haven't started project 3, this is going to be like the planning phase for project 3, okay? It's going to emphasize the aspect of decomposition so that then you can sort of, attempt each of these smaller steps with more confidence, or maybe with like a higher chance of success. And I'll go over like sort of what my answers would be to this as well. But let's start with this activity, okay? Hopefully y'all can access the bit.ly form here. What I want y'all to do is list out like a numbered list of what you think the steps, or like the smaller steps of doing project 3 are going to be, okay? This is just like a 1-sentence description of what project 3 is. Remember, there is like a whole write-up on the website as well. But let's take a few minutes for y'all to plan out how you're gonna decompose project 3. And to this, you don't even have to say specific file names or function names or anything. I'm not looking for that level of detail, just maybe several like high-level steps of how you would accomplish this. You probably don't even need to look at the code base for this, okay? You can just do it without even looking at the code. a minute, maybe you can start submitting this. And then also with the person next to you, just exchange like lists or look at each other's lists and then just compare for like overlap.
Yeah, it's like I think he's like one of the examples that figured out something. I guess, oh yeah, so there's like two pieces. Alright, everybody, go ahead and submit the Google form. Let's go ahead and submit the Google form, and then we're going to go over it. Yeah, but I'm saying
Alright, let's go over some of these steps here, okay? So hopefully you had a chance to discuss with the people next to you to see like any differences or things that you might not have considered. I think looking through these answers, a lot of them honestly were about maybe like 4 or 5 different steps, which is good. I mean the quantity doesn't matter so much. What matters more is like the actual complexity of each step, okay? And so I want to go over, so this is just one that I copy-pasted here that I thought was a bit representative of a lot of people's. So if this was yours that you wrote, I think good job. This was a pretty good approach. I'm going to sort of talk about what these steps are and how I would make some modifications for Project 3 specifically, okay? So I think the first step, even before, so I think the order could be a bit,
variable. You can start with doing some of these things. I think ideally when you decompose a task well, you can do things in parallel, okay? Like you don't have to necessarily do the first thing to do the second thing, and then you don't have to get the first two things done to do the third thing. Ideally, some of these are sort of like different problems that you've identified that you can work on at like different times, okay? So I'll actually put in my solution from a different slide deck here, and then we'll just keep this on the slides as sort of, maybe some hint for project 3, okay? So this is what I sort of did for this problem. The first thing is going to be figuring out how to add a menu option under options, okay? Again, I think this is like a very narrowly tailored like step and something that you can maybe look at other examples for to figure out how do I actually add something here. The second thing, I didn't see too many people write this down, but I think this is actually a pretty important step as well, where we have to sort of link the menu option to some specific like function or code, okay? And I think a lot of y'all have already seen an example of this happening with the go to line event, remember? So, y'all worked on the go to line event in project 2, and if you sort of go to the references here, you can see that there's this pretty important step that binds this sort of like weird syntax here, the arrow go to line with self.goToLine event, okay? So I think this is something that y'all have already seen in project 2 and is going to be something you're gonna have to do as well for an option under, the options tab, okay? And when I say under the options tab, let me just be extra clear here. I mean that when we have like a new file under options, right? Where it says like show line numbers and show code context. The next thing is accessing the code in the highlighted region, right? So whatever the user highlights, we just need to be able to read that code, okay? Or just like access that code. The fourth one is get the code outline for it. And I'll mention this as like maybe like the main like logical implementation for the project. Maybe we could make this a bit smaller. So I think this step is going to require, maybe you'll have to write your own longer function to do this. Maybe you can find some external library that already shows the code outline or helps you find the code outline. But I think that's going to be maybe a pretty important step here. Okay, then these next two, I think y'all should try to figure out earlier on. I mentioned how in a good sort of problem decomposition, they're not always so dependent on each other. You can understand, you can try to figure out how to write to the Python shell, okay? Remember, what I mean by that is whenever we click, like show code context, or when we click show code outline, the outline should pop up here in the Python shell, okay? So we're gonna have to figure out how do we get the information that we read in from here. Remember, this is going to be like, so remember, there's going to be like some code in the editor window, and we're going to like highlight it, and then we're going to do option show code outline, and then it's going to have to pop up in the Python shell, okay? Y'all can already start figuring out without doing any of the other steps, and in fact, I do recommend this to try to figure out this step early, just how do you write anything to the Python shell, okay? And then you want to like actually add the logic to write to the Python shell. Maybe this is part of the same thing. I think honestly you should start to understand how to do it in a separate sort of substep from like what the actual production implementation is going to be, right? You can just make some experimental code changes in the idle-lib code base to figure out how do I write to the Python shell. Then you can add the logic to write the code outline to the Python shell. And then this last one I like actually wanted to do this activity specifically because this I think a lot of people have not considered, and it was a common mistake in last year's project 3. After writing to the shell, okay, so remember, we're gonna write the code outline here to the shell, but just like how we have, any of these other prompts, it should then have like the next, prompt show up for the user to start working on it, okay? This is like another small step that you're also gonna have to figure out. So not like after you write to the Python shell, it should be ready for the user to just start working on the Python shell again, okay? You can't just leave it in sort of this like invalid state where it's just like it prints the code outline. It should also be usable after that, okay? And that's another non-significant step, but it's something you can figure this out before even doing any of the other features, okay? You could just experiment with different commands on like, how do I actually just get the prompt to show up? So consider this like a hint for project 3, and I think start working on any and all of these steps as needed, and then you can sort of like make your way through the project. And as you come to like office hours for help or post on Extra, maybe you can even really like specify which sort of step on the problem you're on, okay? And I just want to add like one more motivation for this. This is just something that is maybe more interesting for, like maybe not so practical, but something that's really relevant. So this person, okay, John Ousterhout. I had never heard of this person until last year, but he's a really big deal in like the early software systems space. So you know how we're working with like tkinter? Tkinter is sort of like the graphical representation, like tkinter's all these like text widgets and stuff. There's something called TCL, which is just pronounced tickle. That's like tickle tkinter, which is sort of like I think command line like way to have these different like widgets. And so I don't know so much about it. Okay, it's some like non-GUI based like set of commands that was really influential with early software systems. Okay, this person was like a founder of some very big, I think, worked on like Sun Microsystems, which is like I think like chip development, I'm not exactly sure. Also founded Electric Cloud. I don't know what all these companies do, but I know that they're big companies, okay? He came and gave a talk at UCSD last year, okay? Right now he's a professor at Stanford. I mean, he teaches a similar class to this actually, that's more on code design in large code bases, okay? So he did this little activity in the talk where he just asked, like, it was like, so this is a guy that's pretty big in like CS, and so the talk was like filled with a bunch of professors and like grad students, and then he asked like, what do people think is the most important skill for a software engineer? And there are so many different answers, one was like code design, one was like debugging, one was like, into working on your own or something. And then his take on this was just that problem decomposition to him was like the most important trait for a software developer to have. Just the ability to like take some big task like what we have in Project 3 and then like work on much smaller, like breaking it down into much smaller tasks, okay? So that's sort of the motivation here. And sorry, I should have specified, he's the person that created tkinter actually. So like all this code that we're working with, he's like the original, I think him and like one other person wrote the whole like tkinter code base, okay? So all this stuff that we're working with, like sandboxing and stuff, this was started by like this guy working on it in the late 1980s or something, I believe. But yeah, just a little bit of interesting history there and like why this like problem decomposition is something that is very important when you end up like working in industry, okay? Alright, so now let's get to the actual work with Copilot. I wish we got to this a bit earlier in the lecture, but we're definitely going to spend a lot of time on it in the next week. So one thing to note here though is that although we did this activity for Project 3, I think as much as possible, please try not to use GitHub Copilot for Project 3, okay? Project 4, after Project 3, is going to be using only GitHub Copilot, and that's just going to be a chance for you to like literally do all the understanding and the code writing in Copilot. Project 3, I still want y'all to get the experience of the traditional process of like writing a whole new feature, okay? So please try not to, of course, maybe if you have to or you're like really stuck, then you can use Copilot, but make sure to include it in your process journal. I still think for Project 3, try not to use Copilot as much as possible, and sort of will help you as you do it, okay? You're gonna get the chance to use it in Project 4. Okay, so today, for these like last 10 minutes, I'm gonna focus on GitHub Copilot for the code comprehension process, okay? You can sort of think as like the whole process of like adding a new feature to a code base as, understanding the background code first and then making the actual code changes, okay? This is going to be about how do we understand the actual code for some feature, right? So let's go to our workspace. I'm actually gonna open the format region class. So a couple things to check and make sure is first, when you click on this GitHub icon down here at the bottom right, it should say status ready, okay? The way you can make sure that it actually will say that is you can check your extensions. You should make sure you have GitHub Copilot and GitHub Copilot Chat, okay? Please have both of these installed. You're going to be using both of them extensively in these next 2 lectures and also the project, okay? Importantly, make sure you also have chat, okay? Not just GitHub Copilot. So if you have both of those and the status is ready here, then you should be able to, and of course make sure that they're enabled, then you should be able to sort of do a lot of the things that I'll be demonstrating right now, okay? So, first is like, how do we even just start interacting with GitHub Copilot? So there's sort of two ways to do it. One, you'll see, you'll see this option on the left, which is like the little chat box, okay? This chat thing is just GitHub Copilot chat, okay? And this is, similar to ChatGPT, just one of these like large language models. But the interesting thing here is that you have these different commands, okay? So when you do this backslash, you'll see a few different options here, okay? We have like explain, we have at terminal, explain, VS Code, like fix, new notebook, test, etc. Okay. One really important one that I want to highlight here is this at workspace annotation. Okay. What this at workspace thing is going to be really important to include when you're asking questions specific to the idle code base. Okay. When you specify this at workspace, what it's actually doing is guaranteeing sort of that we are going to be using data from the editor as part of like the context for it to answer our questions, okay? If you don't do this at workspace, it'll just give some general response based on the training data that it already has, okay? When you do this at workspace, and I'm going to show an example now, it'll actually look through like all the files that you have in your currently open project directory, and it'll tell you what parts of the code base it's actually using to deliver the answer, okay? So let's say I want to, what was I gonna do for this one? Oh yeah, I want to understand, let's do the uncomment region event, okay? So I want to understand the uncomment region event. Let's just try this and see what happens. So first, you'll see these like initial steps. It's determining the workplace structure. It'll start looking for the information in the workspace to collect, and then it'll actually tell you, okay, so let's let it reach out, like write out the answer. But it'll actually tell you here, you see it says use 6 references. You can actually click on that, and I'll do that in a second, and it'll tell you where exactly in the code base it's like using the context from to give you your answer, okay? So let's see here. It looks like it used format, like all the stuff was from format.py, then it also looked at the test cases and it used the README, okay? That's pretty awesome because it also kind of covers maybe some of the things that we have already done, right? You can see maybe it looked at indent region event, it looked at dedent region event, comment region, uncomment region. Okay, I thought it would have started talking about, oh yeah, get region and set region. I guess it talks about it here. But that's pretty interesting because, we sort of talked about like the code navigation techniques. We talked about reading the test cases, reading the documentation. You can kind of see how this is like an automated way to do that, right? It's sort of like using the things that we would have like manually done, but doing it, feeding it into a large language model or fine-tuning a large language model. So let's just look at like sort of the answer that it comes up with. And I actually chose this one. I experimented with a lot of different features. Sometimes the explanation is like not accurate at all, okay? So I'm gonna show a couple examples of that after the activity that y'all do today. Oh man, we might not have time for the activity. We might have to save it for the next one. But I think the answer for this one was actually a lot more reliable, okay? So let's take a second to read this. It talks about the uncomment region event being part of this class. It gives like a very detailed description of like how it works. And then I think, it just shows the actual region here, or it shows the actual piece of code here. So maybe here we could just have, let's do the same sort of prompt without the at workspace command, okay? And let's just see what happens. I actually don't know what's about to happen. Let's see. So let's do like, can you explain, what was the one? In the idle code base. Oh wow, maybe it does use, what's currently open and active. Okay, so you can see actually the difference in the response here. It says the uncomment region event is not present in the provided code snippet. I think maybe if you like highlighted or specified that you want it with the workspace. Yeah. Oh, that's probably why it said it's not in the provided snippet. Let's try that again. Thanks for that. Let me save it. Now let's see what happens. Oh yeah, it was an indent region event, right? Yeah. So I mean, I think this will be a very similar. Yeah. Okay. So it actually didn't. Even though it was still there, it's still not able to like actually read it, right? That's just sort of emphasizing to use the add workspace command. Okay. I actually made this mistake a couple times last week when working on the project core that we're gonna release. So yeah, that's just maybe some helpful tidbit there. Let's see what else I wanted to cover for this. Oh yeah, okay, so the next one is so I mentioned one way to like interface with GitHub Copilot is using this chat thing. Then I think maybe the more powerful one is the inline sort of like interaction, okay? So what I mean by inline interaction is, let's take this function, okay? This change indent width event. Wherever you have your cursor, you can do Command I, okay? When you do Command I on a Mac, this little thing will pop up, okay? And here, what you can do this like backslash again. You're given more limited options because this is specifically like the inline interface for GitHub Copilot, okay? You're limited to this doc, explain, fix, and test options. What you really should do is like you should highlight whatever piece of code you want to run an operation on, okay? So I'm gonna highlight the whole method. I'm gonna do Command I, and when I do this slash, I'm just going to do doc, okay? What this doc command does, as it says, it adds documentation for this specific function. I think this is really useful. You'll notice that there's quite a few functions in this code base that don't have any documentation. And as a result, it's a bit harder to understand, okay? This is gonna be a really helpful way for you to have GitHub Copilot like generate documentation for each method, which is like a really helpful way to actually understand what that method is doing, okay? So what actually happens here is that it suggests some changes and then you can either accept it or discard it. What you might want to do first is actually like read the actual suggestion before and then make a decision. But here it looks like it says it's an event handler for changing the indent width. And then the sort of like standard format that it always uses to add documentation is it'll tell you what it thinks the arguments are. So here the only argument is event. And then it'll tell you what the object is that it returns and sort of like what that object means, okay? So I'll just choose to accept this right now, and then you can see that it actually generates it, and I think this is maybe a bit more straightforward method that we don't need it to understand, but I think there's some other ones in the code base that maybe are in editor.py related to like getting a line number that would benefit a lot from having like this documentation for, and it's something that you can use to also understand the method, okay? I think I'm gonna go ahead and wrap up there. We didn't get to this activity too, but let's save that for next lecture. This is a much more complicated feature that is a lot more complicated than this like uncommon region event. We're gonna have y'all use Copilot for like 10-15 minutes to try to understand that complicated feature. I think today we can just think of it more as like understanding at a high level what Copilot is, what some of the features can do. But let's hold off on doing this activity until next lecture. Okay, next lecture we'll spend maybe like 40 or 45 minutes of y'all working on Copilot. I wanted to have more time today with that, but we'll move that to next lecture. Last couple things, these are just closing announcements. Make sure you get exploration activity 2 done. Please do the week 5 reflection survey by the end of this week. Group project proposals, come to office hours for it, and then we'll walk through the presentation. Okay? Thanks everyone. See y'all.